Hi students, in this lecture I am going to discuss problems. Let us see first one. A 4 microfarad capacitor and a resistance of 2.5 mega ohm are in series with a 12-volt battery. Find the time after which the potential difference across the capacitor is 3 times the potential difference across the resistor. So condition is potential difference across capacitor is 3 times the potential difference across the resistor. So we have to find the corresponding time, right? So given for 2 marks in 2005, let us see. So first note down the given data. Given resistance equal to 2.5 ohm, 2.5 mega ohm, and capacitance 4 microfarad, and condition is that okay, battery EMF is not 12 volt, and the condition potential difference across capacitor is 3 times the potential difference across the resistor. Okay, let us make a diagram for this one. A capacitor and a resistor, and this is a battery, right? So the CSB, which is equal to 12 volt. So first we have to focus how to find the value of VC. We are knowing that charge as a function of time. During charging, Q equal to Q naught into 1 minus e power minus t by RC, right? And here Q naught equal to, it is, right, it is given 12-volt battery in series, right? That means here Q naught equal to capacitance C into Q equal to C into V, right? V value 12. Now from this we can write Q equal to C into V, or this is, we can say, potential difference across the capacitor, that is equal to C into V into 1 minus e power minus t by RC. Okay, now C gets cancelled. So VC equal to V into 1 minus e power minus t by RC. Okay. Now take the given condition. First of all, find the value of RC. RC value means time constant. RC equal to R value 2.5 mega. Mega means 10 power 6. 10 power 6. And coming to capacitance 4 micro. So 4 10 power minus 6. That is equal to 10. Okay. 4 into 2.5, that is a 10. Next, see the condition here. So VC value is known. We can write VC plus VR is equal to 12. See carefully circuit diagram. Potential difference across capacitor. Potential difference across capacitor plus potential difference across the resistor, sum must be equal to 12, right? Now in the place of VR, see what we can write? In the place of VR, we can write VC by 3. In the place of VR, we can write VC by 3. That is given condition. That is equal to 12. So it is now 4, 3 plus 1, 4. 4 VC by 3. That is equal to 12. Right. It is 4 VC by 3. That is equal to 12. So 4 here in 12, 3 times. That implies VC value 9. Okay. Now see here VC value 9. Take in this equation. VC is 9. V value 12. 1 minus e power minus t by 10. Okay. See how much we get. So 3 times and this is here 4 times. And if I'm taking reversing this one, 3 by 4, 1 minus 3 by 4, 1 by 4. That means we can write 4 equal to e power t by 10. Check it once. 3 by 4. So 1 minus 3 by 4, 1 by 4, 1 by 4, reverse it, 4. So 4 equal to e power t by 10. Now take ln on both sides. Ln 4, that is equal to t by 10. Okay. And that can be written as ln 4 taken as 2 ln 2, right? This is 2 square. So 2 ln 2. So 2 ln 2 is equal to t by 10. And given that ln 2 0.69, 2 into 0.693 into 10, that is now t value, right? So t value how much means? It is 13.86. So it is just writing the given condition. This is a given condition. How to find VC? Q equal to Q naught into this value in the place of Q. Capacitance into potential difference across the capacitor at that instant. That means V also in the same way. VC equal to V into 1 minus e power minus t by RC. Okay. Let us see in next one. Let's see the question carefully. At t equal to 0, a battery of 10 volt is connected across points A and B in the given circuit. If the capacitors have no charge initially, condition is initially they are uncharged. At what time in second does the voltage across them become 4 volt? So almost same as the previous question, right? Connecting a battery of 10 volt. At what time it becomes 4 volt across them? Then see what we can do. He's asking across them means across the capacitors, right? Because asking here if capacitors have no charge initially at what time does voltage across them means across the capacitors it should become 4. Then see how to solve it. Given ln 5 and ln 3. At first see the given circuit diagram. Given 2 milli in series, sorry, parallel combination 2 and 2. And next given 2 capacitors. Again in parallel combination and see their values 2 milli, sorry 2 micro 2 microfarad. This is 2 mega ohm. So first what we have to see here, what is a time constant? So time constant equal to effective R value. Since these two are parallel combination, it is 1 mega ohm. So 1 10 power 6. Coming to here, capacitors, they are in parallel combination 2 plus 2, that is of 4. So 4 micro, right? So it is equal to 4 second. That is now time constant. Okay. And just now we have discussed. So we see potential difference across capacitor is equal to V into 1 minus e power minus t by RC. So t by 4. Okay. And given V value, it is a 10 and this is now 4. So 4 equal to 10 into 1 minus c by t by 4. Okay. Now see calculation. 4 by 10, that is 2 by 5. 2 by 5 equal to 1 minus e power minus t by 4, or it is e power minus t by 4 equal to 1 minus 2 by 5, that is 3 by 5, or that implies e power t by 4 is equal to 5 by 3. Okay. Now take ln on both sides. Ln on both sides. It is, if you take ln on both sides, t by 4 is equal to t by 4 is equal to ln 5 minus ln 3, right? And we are given ln 5 value 1.6 and ln 3 value 1.1. So that is equal to how much? It is a half, right? So t by 4 is equal to half. That means a t value, it is 2 seconds. That means after 2 seconds across the capacitors, potential difference becomes, it is 4 volt. Okay. Let us see next one. Right. See the question. At t equal to 0, switch S is closed. At t equal to 0, switch S is closed. The charge on the capacitor is varying with the time as Q equal to Q naught into 1 minus e power minus alpha t. Obtain the value of Q naught and alpha in the given circuit parameters. Right. So first of all, focus what is given here. Given R1, R2, it is closed. So if you want to get here, so first we have to focus what is the time constant. So to find time constant, we have to focus across capacitor. What is the equivalent resistance? So step 1, remove the battery. Step 2, connect by a conducting wire. Okay. Now across the capacitor, these two resistors are in parallel combination. Okay. Let us see diagram once. So given R1, R2, so capacitor, okay, across capacitor, it is given R across given R2. So R1, R2, This is now C. So there is a battery. So it is V. So when switch is closed, so first we have to focus what is the time constant. So given expression is Q equal to Q naught into 1 minus e power minus alpha t. Okay. Just compare this with our standard form. In the place of Q naught, it is maximum charge into 1 minus e power minus t by tau. That means here what is alpha? 1 by tau is nothing but alpha, right? Okay, now how to find time constant? So across the capacitor, so we have to find out what is equivalent resistance. So step 1, remove this battery, connect by conducting wire. It is by conducting wire. Then R1 and R2, they are in parallel combination across the capacitor. Therefore, time constant will be, since they're parallel, effective value R1 R2 by R1 plus R2 into C. So we have to find alpha. Alpha means 1 by tau, right? So reverse of this. So we got the value of alpha, right? So now we have to find Q naught. Q naught means maximum charge on the capacitor. Okay. So charge is a maximum when it is completely charged. What is it? Charge on capacitor is maximum when it is a completely charged. Completely charged means there is no flow of current through the capacitor. So current flows only in the outer part like this. Okay. That means now we can say in steady state. Steady state means capacitor is completely charged. In steady state, current flows like this R1, R2, right? So current equal to V by R1 plus R. Now you can see potential difference across R2 is nothing but across the capacitor because R2 and C, these two are parallel, right? R2 and C, they are parallel. So potential difference across R2 is nothing but potential difference across the capacitor. Therefore, potential difference across capacitor maximum value how much means it is equal to current is V by R1 plus R2 into R2, right? So this is a current V by R1 plus R2, that is a current into R2. This gives potential difference. Okay. So this is now potential difference. Then charge will be, so Q naught is equal to, it is C into potential difference across capacitor. So it is now CV into R2 by R1 plus R2. Okay. So we have to focus maximum charge means it is completely charged. So since completely charged, no current in this branch. Only current flows like this. Then we are finding potential difference across R2. That is nothing but potential difference across the capacitor. Once we know potential difference, charge equal to capacitance into potential difference. Okay. Let us see next one. In the circuit shown, the battery is an ideal one with EMF V. The capacitor is initially uncharged. The switch S is closed at time t equal to 0. Find the charge on the capacitor at time t. Next, find the current in AB at time t. What is its limiting value? as t tends to infinity. Okay. So asked for 8 marks in 1998. Let us see how to solve it. So first see the diagram as which is given, and there is a battery, a resistor, and one more resistor. And this is now capacitor. So this is now switch. I think all are equal, right? R. And this is now capacitor, point A and point B. So we have to find a charge on capacitor as a function of time. So Q as a function of time, right? Right. See what we can do here. So we can simplify like this. This is equal to maximum charge into 1 minus e power minus t by tau, where tau is known as time constant. Okay. Now, first focus like this. What is maximum charge? What is maximum charge? Maximum charge means capacitor is fully charged. Capacitor is fully charged means current flows now. Current flows now when it is closed. Current flows like this side. Current flows only in this branch. No current now in this way. Therefore, current how much means this is R. This is also R, 2R. So current means it is equal to V by 2R. Okay. So when current is V by 2R, we can see across this resistor, there is no potential difference because there is no current flow like this. So potential difference across AB is nothing but potential difference across the capacitor. I hope you are getting this point. There is no flow of current like this. Okay. Therefore, across the resistor, there is no potential difference. So, across AB, potential difference is nothing but potential difference across the capacitor. So, across AB, potential difference is current is V by 2R into its resistance. That is now V by 2. So, across capacitor, potential difference how much? V by 2. That is maximum. Therefore, maximum charge how much means C into V by 2. That is a Q naught. Next, we have to focus time constant. And to find time constant, we have discussed that across the capacitor, find the equivalent resistance. Across capacitor, find equivalent resistance. So step 1, remove the battery. Then connect by conducting wire. Then see what happens. If you remove the battery, then both resistors R and R, they are parallel. This is now capacitor. This is R. You can see now these two parallel. So it is R by 2. R by 2 and this is R in series. So R plus R by 2, 3R by 2. So time constant is now 3R by 2 into C. That means directly we can find a charge as a function of time on the capacitor, right? So next we have to find out what is the current in AB as a function of time. So now we have to focus very carefully. Let us make circle diagram once again. Now see the second part. To find current through AB, so this is now battery having here one more resistor and here one more, and this is now capacitor when this is a closed. Now see carefully. Current flows. Let us say current is I. Now we have to find current through AB, right? At junction, current divides into two parts. Current through capacitor, that is IC, current through AB. Okay, two parts. And we got now Q equal to Q naught. And the value of a Q naught is C into V by 2 into 1 minus e power minus T by RC. We got, see how much tau value? We got 3R by 2 into C. This is now 2T by 2T by 3RC, right? This is a charge as a function of time. Now, if we differentiate this, we get current, right? Differentiate that, see how much we get. CV by 2 into 2 by 3RC into e power minus 2T by 3RC, right? Now see calculation part. Calculation part. 2 gets cancelled. C and C gets cancelled. V by 3R into e power minus 2T by 3RC. Okay. That is a current through capacitor, IC. Now current through AB. Current through AB, that will be equal to, it is I minus IC. Okay. We know IC value, but I value is not known. So if we know I value, we can get IAB, right? Now to find that, see what we can do. So take here loop equation. Suppose this is AB, CD. So I'm taking the path D, A, B, C, D. This is the path I'm taking. So coming to here, in this one, it is minus IAB into R coming to B to C. It is now I. So minus I into R, because this IAB and IC, right? They combine at B. So minus IR plus V equal to 0. Now see what we can do. In the place of IAB, what we can write? I minus IC, right? Substitute there. It is I minus IC into R minus IR plus V equal to 0. Now see what we get from here. The value of I minus IR minus 2IR, or you can say 2IR minus, if you multiply with minus throughout, minus, it becomes a plus, it becomes a plus, it becomes minus if you multiply, okay, with minus both sides. So IR, 2IR minus ICR equal to V. That implies I equal to, see how much we get? V by R, wait, it is how much we get here? I have taken R here, V by R, remaining is V by R plus IC It is now half of that, right? Means by 2 by 2. Okay. Now substitute that in this one. So IAB is equal to, in the place of 5, writing V by 2R plus IC by 2 minus IC. Okay. That means it is how much? V by 2R minus IC by 2. Now in the place of IC, write that value. It is V by 2R minus V by 6R e power minus 2t by 3RC. That is a current through AB. Okay. And asking here, what is a limiting value as t tends to infinity? Now in this, if you take a t value infinity, e power minus infinity, that becomes now 0. So this is 0 means limiting value how much? V by 2R, right? That is limiting value. Okay.